Hello, and once again, welcome to this course where we'll be continuing to create a hex-based strategy game in Godot engine using C#. So to refamiliarize and reorient ourselves with where we left off, let's take a look at what we have thus far. So last time we created some terrain generation that allows us to generate pretty nice looking ocean and continent terrain for a map based on hexes. And we also have some basic zooming and panning controls for that map. In this course, we're going to start to add some interactivity to our map, being able to select tiles, give attributes to tiles that will affect gameplay like food and production values, and eventually add cities to our map. As it stands right now, there's really no way to interact with our map other than our zooming and panning controls. So before we can do anything else in this course, we'll need to create some system to be able to have our map be clickable. For our map to be able to know that when we click this tile or this tile, we want to know what tile that we're selecting and have some actions be able to be taken as a result of that click. So in these first few videos here, we're going to be implementing a system to do just that. So before we do anything too fancy with this, let's just get some basic interaction on our map. What we want here for this first iteration is going to be something very simple. We want to be able to click on a particular tile and be able to print out what tile we just clicked on. So we actually have everything already set up as we would need it in the editor for this. So let's head over to VS Code and start writing the logic. Alright, so here we are in our hex tile map C# file in VS Code. To re-familiarize ourselves with this file here, we've got two classes in here. We've got our main hex tile map class that's doing all of the heavy lifting for our map logic. And then we also have this little helper class hex that we want to use to represent a particular hexagon on the grid. Right now we can see this class is pretty bare bones. It just stores a terrain type and some coordinates. So we're going to keep it mostly like this for now, but what we want to do is add a little helper function that will make printing this out easier as we test our map. So let's add an override of the toString function. So this is actually a C# feature that allows you to define a string representation for a class so that you can just directly call print on it. So we're going to do a public override string to string. Okay, so VS Code populates this for me. So override, if you haven't seen this in C#, this basically means that we are implementing this method. This method is present in the superclass. So in C#'s case, I believe this is on like just the basic object class that kind of overarches every object in C#. And so any object that we create, we can override this method to create a string representation for it. So what we want to do is just return a string representation. So for now, all we're going to do is return a formatted string that prints out our coordinates and maybe our terrain type. So we're going to create a new formatted string. To create a formatted string in C#, you use a $sign before the string, and then we can input variables onto here. So we will say coordinates, and then we can put variables in curly braces here. So we can say this.coordinates.x. We'll put these in parentheses. Then coordinates.y. And then we'll also add a terrain type. Okay, cool. So with this in place, we are ready to start writing the skeleton of how we're going to interact with the map using the mouse. So in Godot, if we want to poll for user input on a particular class, there are several methods that we can override to accomplish that. And so in this one here, in our HexTileMap class, we're going to override a function called Unhandled input. So right above our generate terrain function here, we're going to create another override function, and this is going to be the unhandled input method that Godot provides us. So the reason we want to use unhandled input here is actually thinking a few steps ahead to when we're going to implement a UI system for our game. So what unhandled input basically does is it will only detect, say, a mouse click if that click hasn't already been what's called consumed by another element. So this basically lets us avoid in the future, when we have a GUI, the problem of, say, a UI element being over the map in 2D space. And so in that case, we wouldn't want the mouse click that, say, clicks on a button on our UI to also be registered as a click on the map. And so by only polling for unhandled input, that is to say input that has not already been consumed by another element in the world, we will allow us to avoid this issue. So the very first step here to polling this unhandled mouse input is to actually detect a mouse click event. So if you've done user input polling in Godot before, this will be familiar to you. But in C#, it goes like this. So if the event, that is to say the input event here, is of the type input event mouse button, you can see there's all sorts of input event possibilities here. So if it is a mouse button, we will call it mouse. And then we will go into this block to handle the mouse click. So with this, we have a nicely set up skeleton for filling out the rest of our mouse click map interaction controls in the next video. So thank you for watching, and I will see you there. Hello, and welcome back. In this video, we'll be continuing setting up our basic map interaction using Godot's unhandled input function to poll our mouse clicks. Okay, so to reiterate, what we have so far is we have overridden Godot's built-in unhandled input function, and we have written a if statement to check whether the input event is indeed a mouse click. So now that we know inside of this if block that it is a mouse click, we can go ahead and start actually translating the mouse coordinates into map coordinates. So on its surface, that can sound like a pretty daunting task, and in a lot of scenarios in game development, it really is a pretty daunting task, since converting between screen space and world space and local space, that is to say the coordinate system of local objects in a scene, can be really complicated. But thankfully, Godot makes this pretty straightforward for us. Fundamentally, the problem here is we need to convert from our mouse coordinates, which are going to be given to us basically in pixels relative to the 2D origin of the whole 2D world in Godot. Got to translate those coordinates into map coordinates, that is to say the actual hexes on our tile map. Again, Godot makes this pretty easy, and we're actually going to be able to do all of this in one pretty slick line of code. So we'll first create a new vector 2 of integers to store our final output of map coordinates. And here's what we're going to do. And I'm going to work sort of backwards from the deepest nested section here, starting logically with our mouse coordinates. So the first thing we're going to need to do is to actually poll our mouse coordinates. And so Godot has a built-in function for this that's called get global mouse position. So get global mouse position will, as the documentation suggests, return the mouse's position in the canvas layer that this canvas item is currently in, using the coordinate system of the canvas layer. What that means is that whatever default canvas layer that our hex tile map object is on, Godot will return the coordinates of our mouse relative to that 2D origin. So this is all well and good. And for our purposes here, we could actually probably directly convert this to our hex grid coordinates and get on with our lives. But for the sake of demonstration and flexibility here, we're going to add in one more intermediate step that, depending on how the game is set up, and especially depending on how you might want to add to the game in the future, could be pretty important. So remember that get global mouse position, this is not actually returning mouse coordinates relative to our hex tile map object itself. This is returning mouse coordinates relative to the canvas layer in Godot that our hex tile map is currently on. So as our game is set up currently, these two might actually be identical because our hex tile map is set at the origin point of our 2D world in Godot. But imagine a future scenario as we develop our game where we actually want our hex tile map to be able to move or to be able to be placed in different locations on the canvas layer. If we were to only use our get global mouse position here and convert that directly into hex tile coordinates, then we wouldn't be able to capture that movement and our coordinate system would be broken. So to alleviate this potentiality, it's good practice to always convert your global mouse position coordinates into the most local space that you're currently dealing with. And so for this, we can leverage a function that any node2D in Godot exposes, which is called toLocal. So what toLocal will do is it will take these global mouse coordinates and it will convert them into true local space coordinates. That is to say, coordinates based on the coordinate system internal to the node2D that we're working with. So this means that the origin of this coordinate space that we're converting this into is always going to be in a fixed position relative to our map. Because the only thing it takes into account is our map, not the canvas layer that our map is on. And so with that, we can now rest assured that no matter where our map is placed on our canvas layer or in the 2D world generally, that we're always going to get consistent coordinates relative to the map itself. So now we have one final step to do, which is to convert these hex tile map local coordinates, which are still given in pixels, to the actual hex tile coordinates of our tile map. And so thankfully, Godot also makes this pretty easy for us by exposing on the tile map layer node a handy function to do just that, to convert local coordinates of the tile map layer to the logical coordinates of the tile map itself. That is to say, which hex we're currently in. So to do that, we're going to take one of our hex tile map layers, so we'll just use base layer, and we're going to call local to map. There we go. And so with that, we should be able to have access to whatever hex given in XY coordinates of our hex tile map our mouse is currently clicked on. So pretty slick. And so just to do a quick test here, before we, in the next video, clean all of this up and add some logic to handle edge cases and things like that, we'll just do a very quick test of how this worked. So we will just print out to the Godot console whatever hex is in our map data at these map coordinates. Okay, and here we go. This should be all we need to be able to see whatever hexagon we're clicking on. So let's head back to the editor and fire it up. Okay, so we can see, if we look at our console output here, that we are actually able to accurately pinpoint whatever tile that our map is over. Or, sorry, that our mouse is over. So we can see here we're clicking on plains, here we're clicking on forest, shallow water, water, and we can see that our coordinate system is accurately lining up where the very top left is 0, 0, and the coordinate system is accurate. So it might not seem like much currently, but this is actually a huge step forward for adding interactivity to our map, because now we can know what tile our user is clicking on. Okay, so this works pretty well, but there's still going to be some refinements we're going to need to make sure this is working correctly. One of the most important ones is going to be limiting where we can actually click on the map, because if we were to click outside of the boundaries of the map, we would cause errors and possibly crashes. So we'll answer this in the next video, but as a challenge to you, try and figure out what checks we're going to need to make to wrap around this print statement we have so far to make sure that it's only going to fire if a click is made within the boundaries of the map. So try that out as a challenge on your own, and we'll answer it in the subsequent video. Hey again, in this video we'll be finishing up our basic map interaction system with mouse clicks by dealing with a few edge cases. So as we tested out last time, our basic system is working, but there's a few issues. The first issue is that if we click outside of the map in any situation, it's going to throw an error. Because of course there are no hex tile map coordinates outside of the actual map. We gave this as a challenge to you in the last video, and now we'll take a look at one approach that we can use for doing this check. So what we need to do first of all is to limit our mouse click detection to be within the bounds of the map. So heading over to VS Code, recall that we converted our global mouse position to our local map coordinates. And so we have these coordinates available in this vector2 of integers right here. So what we can do before we do anything with these coordinates in the map data itself, we need to have a bit of a limit where we'll only do something with these coordinates if the click occurred within the boundaries of the map. And so we'll need to create another check here. Check whether the map coordinates are within bounds for this click. So what we can do here is just set some boundaries for each direction of the map to tell whether our click was inside of it. So, for instance, we'll do if our map coordinates x value is greater than or equal to 0, we know that we're inside the map from that direction. And we also need to make sure that our x coordinates are less than the width of our map. So here we're bounding our map coordinates to be within the map in the x direction, and then we'll do the same in the y direction. So we'll say if the map coordinates y value is greater than or equal to 0, and if the y value is less than height, only then will we actually be able to do something with these coordinates. One other thing we can take care of here is, as it stands, this mouse input event system is taking into account any possible mouse click, but let's say we only want our left mouse button to trigger anything in this section. So what we can do is we can also limit our mouse button with a thing called button mask. So we take the input event here that we called mouse, and we query its button mask, and if it is the left, only then will we actually start doing anything. Okay, so what we've done here is we have limited our printing of map data coordinates to only happen if the mouse click is inside of the map, and furthermore, only happen if it was the left mouse button that was being clicked. So let's head back over to the editor to make sure that this worked. And here we go. So now we can see we can click anywhere outside the map and there are no errors. But if we click inside the map, we can see that we're getting the printouts as we would expect. Okay, so that takes care of the logic of the edge cases that we have for our map clicking. And so now, to polish this off, we're going to start to implement some actual graphics for clicking on the map. Remember, in the last course, we added this one tile map layer that we called selection overlay layer. And right now it doesn't have anything inside of it. It doesn't even have a tile set. We added this in anticipation of adding map graphics to represent whether a tile has been clicked on or not. And so here we'll start to set this up and finish it up in the subsequent video. So the first thing we'll need to do, as we did with our other tile map layers, is we're going to need to set a tile atlas for it. So same way, we will create a new atlas, set it to hex overlays, automatically create tiles. We'll remove tiles in fully transparent regions. Remove this tile since that's not actually a tile. And there we go. We'll save that. Okay, so now our selection overlay layer has some textures to work with. And we can head back over to our code to actually start working with this. So the most basic operation we can do with this new overlay layer, which, by the way, to recall from last time, we have already gotten in our ready function here. So the most basic thing we can do with this is, if all of these things are true and we've clicked on a valid tile, we want to set that tile to have a little overlay so it looks like we clicked on it. So all we'll have to do here is to set the cell that our map coordinates are on in our overlay layer. So this is one of the great things about tile map layers, is how they're so easy and flexible to use in this way. So the same coordinates that apply to all of our layers like our base layer will also apply to our overlay layer. So we can call setCell on our overlay layer. We will pass in the map coordinates that we're working with here, that again have already been checked to make sure that they're valid. The source ID is going to be 0 since there's only one source on this tile map layer. And we're going to need to set the atlas coordinates of our overlay. So since there are only 2 textures in this atlas, this is pretty simple, and they're organized top to bottom, and we know that the overlay tile is the one on the bottom, so it has a x coordinate of 0 and a y coordinate of 1 inside of our tile atlas. Okay, so let's head back to the editor and see how this works. Okay, so here we are on our map. We can see when we click on a tile, it gets highlighted. But you can probably already imagine that we have some issues here that we need to work with. First of all, it is pretty typical for a system like this to only allow you to have one tile selected at once. So we'll need to find some way to keep track of whatever tile we have selected and be able to deselect it when we select another tile. We also want it to be the case where if we click outside of the map, all of our tiles are deselected. And we will take care of these cases in the next video. All right, we are back with finishing up our map tile selection system. So last time we were successfully able to get a selection graphic to appear on our tiles whenever we had them selected, but we ran into a couple problems. The first problem was that we don't want multiple tiles to be able to be selected at once. And the other problem is we want to be able to click outside of the map to deselect all tiles. So in order to do this, we're going to need to actually have some way to keep track of whatever tile is selected at any given time, so that we can know whether our current mouse selection is different or not from the currently selected tile. So here we are back in our unhandled input function. Right above this, so this is going to be a class member variable. I'm putting it here really because it's only relevant to this function, and it just kind of keeps things together. You could put this at the top of the class as well, depending on your preference. But I'm going to create a vector2 class member that we'll call current selected cell. I'm going to initialize this to a default value of -1, -1, basically to represent a non-selected cell that's not on our map. So this is going to be the variable that we're going to keep track of our current selected cell in. So now that we have that, we can start using it down here. So what we want to do is we want to make sure that if our map coordinates clicked on by our mouse are different from our currently selected cell, the currently selected cell is deselected before we select the new cell. So to do this, we're going to come over here and we're going to write a quick check for if map coordinates are not equal to the current selected cell. That is to say, the mouse click is a different cell than the current one. We're going to set the overlay layer, the current selected cell. We're going to set it to -1. -1 when setting a tile map layer cell, this basically just removes the texture, which is what we want here. So if that's the case, then it's going to remove the already existing one. And then we can keep this that we did last time, which is setting the new one. And then we can also make sure to update our current selected cell to equal whatever the map coordinates are. So now we also need to keep track of whether the click occurred off of the map and to deselect the cell accordingly if that's the case. Let me kind of logically group all these together here. So we know that if anything is happening inside of this if check that is inside the map, so logically we also know that if anything is happening outside of this, then the click was off the map. So we can create an else branch here for logic that we run only if the click was off the map. And so what we can do then is to have this exact same line here. So we're going to set the cell of the overlay layer of the current selected cell, and we'll set it to -1. So this means that if we click off the map, it will just deselect current cell. Okay, and with that, we should be able to have some nicer looking consistent selection on the map. So here we go. Okay, we can see we're clicking here. We click on another one. We can see that we can only have one selected at once. So this really looks like now a proper map selection graphic for a strategy game. Cool, and now we can also see that we click off the map, that selection is gotten rid of. Okay, so now we can really see that a interaction system with our map is starting to take shape. Now, one final tweak to the map before we move on to UI in subsequent videos. We can see that if we zoom in on the map, that everything looks pretty okay, but if we zoom out, we start to get this really horrible aliasing on all of our tile graphics. You can see that it's almost difficult to look at. So aliasing like this is a pretty consistent issue in computer graphics, and there's really no single silver bullet solution to this. But one thing we can do to alleviate this is to lower the opacity of our tile borders to make this a little bit less aggressive. So this will be one final change we make here. We're going to head over to our tile borders layer. I'm going to head down to visibility of our canvas item. We're going to set the alpha, this to something pretty low, something like 40. Okay, and with that, and try running this again. Hopefully the graphics will be a little bit more manageable. Yes, there we go. See, our tiles are a lot less intense, and we can zoom out without it having too bad of aliasing. Okay, and so with that, we have finished up our very basic map interaction and selection. And we're ready to move on to starting to take some steps into creating a UI. So our first steps into some real gameplay interaction. And we're also going to be populating our tiles with resources. It's going to be our first real sort of gameplay element. So a lot to look forward to here, and I'll see you in the next video.